One of Earth's closest neighbors is a dark, jumbled mass of rocks and boulders known as Asteroid Bennu. Bennu was ancient or rugged, survivor of the solar system's chaotic past that may hold clues to the origins of life. In October 2020, a NASA spacecraft called OSIRIS-REx touched down on Bennu and collected a sample for return to Earth. Scientists had expected that this touch-and-no event or tag would have little impact on the asteroid. After a slow descent, the sampler head would briefly make contact, inject a puff of gas, and capture a handful of material. Perhaps it would also leave a small divot at the sample site. A sole footprint in the soil. Or so it was thought. When images of the tag event beamed back to Earth, they were far more dramatic than anticipated. Despite its slow touchdown, OSIRIS-REx had punched through the surface and set off an explosion of loose material. Tons of rocks and pebbles were ejected, radiating outward in a wall of debris. The pictures were stunning, but why did Bennu's surface behave so unexpectedly? The answer involves cohesion and attractive force that can bind molecules together. Cohesion gives water its surface tension and keeps droplets together, even in a microgravity environment like the International Space Station. Granular materials like wheat flour, cocoa, and dust can also exhibit cohesion, which pulls individual grains into clumps. On Bennu, scientists had expected cohesion to act like a bit of glue between the rocks, making its loose surface more solid. But the tag event showed that Bennu's uppermost layers are nearly cohesionless to forming under stress like a fluid. Good analogy is a ball pit. Although the plastic balls are solid, they easily slide past one another and past boisterous children behaving in mass like a fluid. Thanks to OSIRIS-REx, we now know that Bennu's surface is not held together by cohesion but by gravity. Or microgravity with a minute tug less than 100,000th the pull of Earth. On the Moon, gravity is 16% as strong as it is on Earth, and more than 16,000 times stronger than it is on Bennu. As a result, loose material in the lunar subsurface is packed together more tightly, making the Moon's surface relatively firm. If a 50-kilogram mass of solid iron were to hit the Moon at the same speed as the tag event, it would sink into the ground by only half a centimeter. Repeating this experiment at Bennu would yield a dramatically different result. Though the mass would strike with the same force, it would plunge 17 centimeters before stopping over 30 times deeper than at the Moon. Bennu has consistently defied scientists' expectations, as each new finding reveals another facet of this small but surprising world. Using data from OSIRIS-REx, we now have the ability to look back and accurately recreate 30 seconds on asteroid Bennu. On October 20, 2020, OSIRIS-REx made its final descent to a sample site called Nightingale. With its tag some arm outstretched, it approached the surface at 10 centimeters per second, the walking pace of an insect. 1 second after contact, it released a canister of pressurized nitrogen, detonating an explosion of particles and driving material into the tag some head for sample collection. 6 seconds after contact, while it was still sinking into Bennu, OSIRIS-REx fired its thrusters to begin the back-away maneuver. The engine burn lasted for 24 seconds, continuously pushing against the spacecraft and rapidly slowing its descent. Flying debris from the thrusters and the gas release pelted the science instruments, clogging them with dust. 9 seconds after contact, when OSIRIS-REx had sunk merely half a meter into Bennu, it reversed course and began to rise. At 16 seconds, the taxon had re-emerged from the subsurface as the spacecraft continued to accelerate. 30 seconds after contact, OSIRIS-REx shut off its thrusters and drifted away with its sample of Bennu. Almost 6 months later, on April 7, 2021, the spacecraft returned for one last flyover to observe its footprint. At the point of impact was a new crater, averaging 8 meters across and reaching 68 centimeters in depth. Thruster marks overlapped with this tag crater in an X pattern, increasing its volume by as much as 40%. A ridge of ejected material that had been kicked up during sample collection and fallen back to the surface circled the crater like a campfire ring. With the path of gas and an engine burn, though, OSIRIS-REx had displaced 12 cubic meters of granular material. 6 tons of loose rock that may be packed together as lightly as a bowl of popcorn. After a final departure maneuver in May 2021, OSIRIS-REx began a 2-year journey back to Earth. Stowed on board were about 250 grams of Asteroid Bennu, a bounty of scientific treasure destined for future discoveries. Subscribe for more.